All right. We got a short introduction, but I would like to say hi. You know my name now. I'm Raido. I have been Java developer for most of my life. I joined GrabCAD around 3 years ago, and have been doing everything but Java development since. Main focus has been on Rails development and node development. I think that's all from me.
Right, thank you. Thank you, Raido.
Thank you for coming.
I'm Matti. I've also been with GrabCAD for 4 years or so. Right, so this is what we want to talk about today. So we'll give a bit of background about us, because I think it's relevant for the choices we made. And we'll describe what we built, what is the application that we want to present about today. And we'll go through how you would go about building one yourself. And then go slightly longer through what we learned in the process of that. So before we start, just for a bit of background, like who does JavaScript development here? Half or so. And who does desktop development, desktop applications? Well, slightly less. Yeah. Okay, right, so let's get going. GrabCAD. We presented before, but just a quick reminder. So we are a web-based community for mechanical engineers with 3+ million members. We have an online repository of 3D models. We also have a product called Workbench, which is also web-based. It's a collaboration platform for mechanical engineers to build products. So it's kind of like GitHub for mechanical engineers that's web-based. So you don't need a CAD to collaborate. In 2014, GrabCAD got acquired by a 3D printing company called Stratasys. And we've been motivated to look into the world of 3D printing ever since. So who has printed or seen a 3D printer in action? Like very few hands. Okay, that's a bit bad. I didn't plan to go very deeply into the 3D printing world, but the application that we want to talk about is called GrabCAD Print. It is a 3D printing print preparation tool. So it's the tool where you take a model that you modeled in some other software, in some CAD software. And when you want to prepare it, and that's the tool where you say how many copies you want, which side up it should print, what color it should be, this type of thing. So it's print preparation tool for different kinds of printers. We started, of course, with Stratasys printers, but it's meant to be an open platform where other printers can also be supported. But that's to follow. That's to see. Right, so that's a quick intro. Let me now show the application briefly. So, as title mentioned, it's a desktop application. It has a desktop icon and everything. It has a splash screen. And now I need a mouse. Rodent. It's not very visible, which is bad. Let's see if it gets any better. Anyway, it displays the print area of the selected printer that I have open here. It has tools for doing, manipulating the object that I want to print, to describe the settings, how I want to print it. And it has tools for managing the files that I open in a project. So I'll now drag and drop a model here, which is a frog. I can take a look at it. In this application now I can say like how many frogs do I want printed, or how big the frog should be. Oh, Jesus, I can't see anything.
It works on my machine, right?
Yeah, I can make it slightly bigger. I can say where I want it on the tray. I can say which side I want it to be up, or I can say that I want this side to be top outside, which would print really badly. So I'll just undo most of the changes. So that's essentially what the tool is meant to do. Then, when you prepare a tray here, yes? It supports actually CAD file format, so you can open a CAD model. This frog is STL, so the usual 3D printing up. So it supports that as well. But one of the things that this software does differently from most of other 3D printing softwares is that you can open a SolidWorks part directly. It will do the conversion magic itself. Right, so the thing the software does is that it prepares the model that you want to print for printing. It creates a tool path for the printer, which essentially describes how the printing head should place material on a tray while it works. So it's not massively well visible here, but I can take a look at what the tool path looks like. How are the layers? How will they be printed? I can actually go into detail and see on each layer how the head will move on the 3, or like while printing this object, or I can animate it to get a better, like if I want to go into detail of how the thing will be printed, then that's the view where I can do that. Right, we don't have printers with us, but I'm connected to our office and I can see our 2 printers. You can't see the cloud icon here, but it says that it's connected over cloud. So now what I can do is I can send this to a print. It will do the print preparation step, and then, which it already did, and it will queue the job, which if the network works, it will do in a couple of seconds now. Let's give it a bit of time. Right, this view that we looked at here is a 3D printing preparation view. We also have a schedule view, which shows printers, and it shows what the printers are doing in time. So I can look at what it will do. I don't see the dates here. It's the calendar view. You can queue the job here. Trust me.
There's your name on it, yes.
Yes, it says my name here. Yeah. So this view is kind of empty right now because in Tallinn office we only have 2 printers that it can view, but I can open another office that I have access to. And this view makes slightly more sense. So
where is this office?
It's a US office in Eden Prairie in Minnesota. They have more printers than we do, and I can see that, oh, this printer is printing and it is out of material, too bad. Right, so in short, that's the application. What makes this application special is that if I do a magic incantation, then I can open a view that may be familiar to a lot of you, and I can take a look at the DOM that is behind this application. So essentially, this is a single-page web app that is running on top of Chrome on Electron that looks like a desktop application, but it actually has the usual Chrome goodies behind, or like beneath it. I can go to a console, I can see the JavaScript, I can see what's running it. Right, so I guess that much about this application, but I'll want to show one more thing quickly. In addition to the desktop application, this is now a Chrome browser, a proper browser. You can't see it, but it's a browser, trust me. I have opened GrabCAD.com, it's a print GrabCAD.com site. We also have some of the components that you saw in the application available through web. So you don't need to run the application if you want to check out if your print is still working. So you can open it in the browser. It's the exact same component that you saw in the desktop app. And you will see it over the network, even on your mobile, I guess. Right, but let's switch back to presentation. I guess that's the short of it. So now let's move on how you would build one of those.
Just a second. I would like to get my notes back. Where are those? Presenter view. Yes, please. Thank you. Let's put it full screen. You saw too much already. Right. As Matti mentioned, the application he showed is built with Electron. Who doesn't know Electron, I will just briefly recap what's it all about. Electron itself is just a framework, basically for creating native desktop applications using good old web technologies such as HTML or CSS and JavaScript or any derivative. It also has cross-platform support, so you can just write the application more or less once, and it will run under macOS, Windows, Linux, almost flawlessly. Basically, it's a Chrome browser. You saw the dev tools, but there is one exception though. The security model is a bit looser, so you will actually have access to file system. You will have access to the user shell and also access to node.js API, so you can do more with that. There are a couple of examples which are built on top of Electron. Most notable ones are probably the add-on that started all of this. It's a text editor that probably all of you have seen or heard at least about. I'm also pretty sure that most of you use Slack nowadays. This is also built on top of Electron. And one of the big names is Microsoft, who also created a tool on top of that framework, which is Visual Studio Code. All right, that's that. I just wanted to give you guys a brief overview how to build an app, and I have prepared a video actually because I'm super clumsy and I make mistakes, and demo guys usually don't like me that much. So in order to avoid embarrassing situation, I just recorded that and I will play it to you guys and I will guide you through. I'm starting with an empty desktop, I will create a directory there where my project will live. So basically, I'm creating a Node application in a moment. Yikes, the color is not so great. So what I'm doing, I'm just initializing the empty directory. I'm saying, this is now a Node project. Nothing magical going on here. Right, and I can see the manifest file has been created. By the way, I wanted to mention that I'm using Atom Editor, which is Electron app, for creating another Electron app, which is kind of nice.
Bootstrapping.
Inception. All right, I need dependencies first, so I have not created any files yet. I will download the Electron in order to start from somewhere. I have sped up the video a lot, so we don't have to wait until the 70 megabyte bundle comes down. I also need a couple of files. One of them is the main script, which will be invoked first when the application starts, and the other HTML file will be used as a GUI for your application. So not very interesting right now, but that's the simplicity of this project. Let's add content. I have created a snippet here just to avoid typing, and I do a lot of mistakes while I'm typing. So let's see what's in that file. First, I'm just saying that, hey, Electron, whenever you feel like you're ready, let me know, and I can open a window that's visible to the end user. And it will load the URL there. It could be any web page, basically, but I'm loading a file from my own file system. And with browser windows, I can actually create like 7 of them. It doesn't matter how many. I'm just declaring here, when the last one closes, please also exit the application. Nothing magical, simple stuff. Also, I'm creating a template for HTML. I think everything so far has been really straightforward. So this is an app. It has a title and some ugly content, but it will do for now. And yeah, I want to show the same. It's actually essentially a browser underneath. So let's add a menu. The beauty of Electron is that you can make the application look and feel like a native application. So to get the sense that this is no longer a web page, I will be adding a menu on top, which is outside of the browser window, at least under macOS. So basically, I'm just declaring a JSON object that says how to behave. All right, let's boot up Electron again. As you can see, the menu is there with custom items. Already looks like a real thing. OK, let's see what's coming up. So as Matti demoed, we had the nice 3D viewer thing in the pre-preparation view. We are using a library called 3JS to render 3D models on screen using WebGL. So I will be doing something similar. I will create a script that will create a spinning cube on the window. Right? Don't pay too much attention to the source code here. It's just a client-side JavaScript file that will be included in the HTML file that will do that. It will work also in the browser, more or less. Before I start, I need to install the dependency for 3JS. And then I will just boot up the application, and I'm done. Right? This is my application, has a menu, looks like a kind of neat. That was my demo. I think there's not much I want to say about it. Matti, take over.
Yep. Okay, let's move on. Let me get the speaker notes back. Tricky bit. All right.
Yes, there is one. Okay. One thing I forgot to mention is once you start doing development with Electron, the first paragraph in your tutorial will say that make sure that you understand what is renderer process and what is main process. So the main process is something you can think of as server-side JavaScript. It's like a headless mode of running your application. It's something you run from your command line, which eventually is able to spawn browser windows. And the stuff that's running on browser window is the renderer process. If you check your task manager, you will see also like there are actually separate processes for everything. Renderer process is running as if in browser, but it will still have access to Node APIs, and it will actually have access to file system. But it's just, you need to understand before you're starting doing, otherwise you will not understand why my debugging doesn't work or how things are built and put together. So in our example, when Matti showed you the splash screen, we are making use of the inter-process communication. So it's said at least. It's a way for main process and renderer process to talk to each other. When we run our application, main process starts. It will create two windows, one on the left, one on the right. Left one will be visible immediately. It's just a web page, actually. There is no menu or anything, but it's just a web page. The right one will also start loading, but we will hide it at first. Once the right one feels like, hey, I'm done, I have loaded all my JavaScript, I have done my initialization, whatever, then it will signal the main process that, hey, I'm done. Main process can decide that I can get rid of the first window and make that one visible again. So two windows don't know that the other one exists. Every communication is just happening between the main process and renderer process. All right? Easy enough, I think. Well, that's all for now.
That's the intro. Let's step back now. Now we have a bit more context. Let's step back to the application. So I'll just describe briefly of what the architecture of the GrabCAD Print application looks like. So it's that is the architecture in the renderer process. We run everything in one window. We don't have multi-window support right now. So that's how we built it. The application here is a single-page web application in a frame, and it has external dependencies that it depends on. We run a bunch of processes outside of the UI itself. So a lot of the functionality that is in the print preparation is something that we didn't invent in the since 2014. It was already there. We are reusing heavily other print preparation software that was there for Stratasys printers. And we chose to run them outside of the process as separate items, and we talk to them using the technologies listed here, ZeroMQ and Protobuf. So the application itself is a modular application. We have, for example, a module for doing the print preparation itself. So that also has subcomponents that do the 3D rendering and subcomponents that do a lot of the calculation behind like how to place things and tray. But let's view it as a one thing. And there's also a module for the schedule view that we saw where the print jobs are visible. These are relatively context independent. So they can be run in not only within this app, but you saw the schedule, for example, running in a browser where it doesn't have access to, say, networking functionalities as easily. It needs to take cores into account and things. These modules rely on a layer of services, which is an abstraction layer behind the functionality that they provide. The services layer also doesn't provide all of the implementation, because a lot of the actual implementation runs outside of the process, but it provides an abstraction for the modules of like the things they can rely on. The application itself is plugin based, so we have plugins that support different printer families. We have, for example, a plugin that provides the cloud connectivity, which you saw me using, which gives me access to the printers remotely while I'm not in the office or wherever the printers are. And we have the desktop layer in the middle. Desktop is the layer that actually provides the frame for the application. So it bundles up a bunch of plugins that it boots up during application startup. And these provide the functionality that actually runs in the application. So, for example, there are plugins that provide access or support for a specific family of printers. These talk to an external service to actually provide that and register themselves as providers of that functionality in the services layer, and then the context-independent modules can actually run. Yes.
So can you add different plugins to each instance of this 3D print application, or certain set of plugins are shipped within a version?
Right now, we don't have any hot loading of plugins or anything, so it's shipped together, but there are different this application that you saw is one instance of it, but there is a sister application that looks very much like it, but supports only MakerBot printers. It has a MakerBot printer plugin that it loads instead. Right. And one thing I didn't mention so far is that the modules actually are relatively independent on how you can implement them. So the schedule that you saw that was on the web and in the application is actually an Angular application. We started it slightly before we started the desktop application project. And then the print prep view, there we use React. So the application is built on top of React. We use immutable models to do our undo stack, for example. And you can actually mix and match those in a single web page app relatively well. So they play well with each other. And you can just use those technologies pretty nicely. Right, and the communication, yeah, as I mentioned, is a 0MQ and protobuf to talk to other services running within the same application, but in the same computer, but in separate processes. The reason why we need that will be explained slightly later. Right, so that's the application. Maybe a brief overview of stats of what it looks like. So the application has been built in the last year and a half or so. It has roughly 160K lines of code together with tests. So I didn't know how to count it separately. So anyway, we are trying out TypeScript. We also have roughly 20,000 lines of code in TypeScript that compiles to JavaScript and runs in the same application. There are roughly 6 major modules that the application is comprised of. It has been built by, well, I looked at the GitHub repo stats of how many committers there are. It has been built by 61 different contributors in 7 different locations. We have a bunch of offices around the world, and we have teams working cross-site. And just as an anecdote, we rely on continuous integration to build it, so that we have a bunch of boxes that run tests, our acceptance test suite, which takes a while. And the cluster of continuous integration is currently at 18 nodes in total. The test suite takes a while to run. We need that for our own comfort. Right, so it's a sizable application written by a not very small team. And let's look at what we learned while building it the last year or so. So I'll start off by looking at the language ecosystem that you need to take into account if you undertake something like that. So if you build an Electron app, then by necessity it needs to run JavaScript code, because that's what browsers run, right? You can write it in something else, but it ends up being JavaScript in the end. So let's look at what it means to write an application in JavaScript specifically, if you don't have that background yet. So one of the things that you need to take into account while doing it is that JavaScript is a relatively unopinionated language. It's quite dynamic, it's open, you can do a bunch of stuff. It doesn't have very many opinions about what style you should use to write stuff. So if you write software with a team, you need to decide, you make a bunch of decisions yourself so that you can actually work together. And there's a bunch of different things that you need to decide. So one of those is the asynchronous calling style. In JavaScript in browser, you may be less familiar, or you don't have that heavily represented maybe. But in JavaScript on Node.js, you have multiple choices of how to call asynchronous code. And everything that is of interest at all happens asynchronously, because it's JavaScript. You can't do computation on the main thread very easily. So you can do async calls using callbacks, which is very common in Node. You can do it using promises, which is slightly different thing, different syntax for doing essentially the same thing with better sugar. Or you can do on Node also, there's a pattern called event emitter, where you start some kind of process and it emits back different events about how it's doing. And you have to listen to those events. So these are all different styles of doing essentially the same thing. And you need to pick one. So we had different opinions about whether to go with callbacks or promises. Right now, we do mostly promise-based calling because that composes well. You can relatively easily compose your different services. Similarly, there's very different ways of how errors are propagated and how you handle those. So you just need to make the decisions how you do those, because in Node.js apps, the default behavior for an error that you didn't handle is to crash. So that's something you maybe don't want in your production application. So you need to figure out how you do the error handling. That's kind of tricky. It took us a while. We had, for a long time, we had actually issues where the errors get swallowed, where you just forget to handle it. It just doesn't show up anywhere, but the application doesn't work. That takes a bit of care and discipline to actually get right, to make sure that all the errors actually show up somewhere to see that they happened. And it's something that you need to take into account and have a style for. One thing that makes it also interesting is that when you have an event emitter type of API that you're consuming, it can emit events like, oh, I got data, you have to take it. It can also emit an error event. And if you forget to handle it, if you don't even know that it raises an error event, then the default behavior is to crash the application. So you just need to find out all the things that you're using and have the own error handler on those, which can be tricky to find out, actually. And also the project style. So if you do Rails projects, then Rails has an opinion about how your files are located on the disk. So it's like every Rails project looks more or less the same. JavaScript projects don't have that problem at all, but that also means that you need to figure out where you put your stuff so that people know where to find files and like how do you structure things. Like, do I have a leap directory? Do I put stuff in a folder? So that's something you need to decide. Right. Then event loop. When you write a JavaScript application, you need to know that JavaScript is single-threaded and it has an event loop. And whenever a function is executing, then the JavaScript engine is not reacting to events. It is executing your function. So every computation, heavy computation that you do in your application will block input for that period while it's running. So that's something you need to know. So we have stumbled upon this. So we have some 3D file formats we parse actually on the client side in the application. If it's a sizable file, you will block the application. There's just no way around it. There are no threads in JavaScript. So that's why we have processes that are outside of the UI, because you can offload work to external processes. That's one of the simplest ways you can approach these things. And you need to know how an event loop works to make the application actually behave nicely. And about the language itself, JavaScript is a dynamic language. It has dynamic typing. It requires some discipline to make an application work across modules. So your modules will pass objects around between themselves, and there is no type checking that you can rely on to see whether it actually makes sense, like the thing that you received, whether it's shaped like you thought it is. So it's quite easy to make the mistake where like two plugins pass you an object that looks like one thing, and then another one passes slightly differently shaped thing that works in two scenarios, but the third one totally fails because it's lacking like a third of the data or something. So the dynamicity of the JavaScript makes it really great to prototype stuff and get things out. But if you want to do like large-scale development, you really need to put some thought into how you define your APIs, how to check your APIs. We are looking into TypeScript to help us define layers between modules, just so that we have more discipline at these areas. So that's where you need it the most, I guess. Right? Then also about JavaScript development, if you do an Electron app development, it's a Node.js application with Chrome in front of it. So you will get the Node.js ecosystem together. Well, you need to take that into account. And the largest bit that I want to talk about in the Node.js ecosystem, the thing that you may have heard of, it's the NPM. It's a package manager for Node. It's kind of like Maven or Ruby Gems or like that kind of things. Downloads dependencies from the internet. It works slightly differently from what I'm used to from my previous experience. It supports multiple versions of a single dependency. That's actually great because you can have your project depend on multiple versions of the same thing, and you don't run into DLL issues. So some things it does really well and right. I'm not sure it's right, but like it avoids some problems by having multiple copies of the same thing in your source directory. Your node directory will have multiple copies of the same thing, like left pad or something you will have a ton of. Right? Just that's how it works. It sometimes stumbles or like make things not work due to this feature because some modules expect to be run as a singleton. So for example, React expects to be loaded once. And if you have two copies of React, then everything goes really weird. Like React doesn't find its own components, and like events don't find where they need to end up. Everything goes haywire. We stumbled upon that. You need to take it into account just somehow. Then NPM, as I mentioned, downloads the internet while building. It does a lot of HTTP calls. That can end up being a challenge. So we do CI, and in order to do clean builds, we clean the project directory before every build, and we do, like with 60 people, we do a lot of commits, so you have a lot of builds. So we download the internet many times a day, and sometimes the internet doesn't work while you're downloading it. NPM's response to network errors is very nice. It just fails. It just breaks everything. So when you see your tests are red, like very often it's just that NPM failed to download something from the internet. So we end up implementing a lot of caching. We run our own in-house NPM caching server using Artifactory, where we have local, not local, it's on Amazon, but it's like our cache with stuff. We also cache on the build agents. So the things that run our continuous integration, we cache locally as well, just so that we don't need to download it from our own server, because that also fails for reasons. Yes?
One question, why you don't just store source code of your models in Git for your source code? I did that a few years ago and it worked perfectly for me.
We have native dependencies. Ta-da! And that doesn't work very well in that scenario. And that is also a challenge. Native dependencies are stuff that include, in addition to JavaScript, also include a bunch of C or something that needs to be compiled. That's a challenge on operating systems that don't bundle compilers, Windows. You need to have a specific version of Visual Studio or some magic setup with stuff, and that breaks all the time. It's just completely broken.
Is it on a Microsoft-specific issue or not?
We have had the issue on Mac as well.
Yes.
Xcode, yeah. With Mac, you need to have special incantations to get it working.
Whenever
we ended up bundling our, like ZeroMQ is a native dependency. We bundled it up for ourselves so that we don't need to build it all the time.
So you should consider with care whether you want to upgrade to the latest OS 6 or not. Like usually there is something in Xcode that changes and you will break everything once again.
But can you just like store binaries and you know?
That's what we built something like that, yes, as in the end. But it's, again, an extra step you need to take. And also, NPM has a weird understanding about how to lock things down. So it's very dynamic. It always likes to get everything of latest. And in order to make your builds repeatable, you want to lock down the versions so that when you check out the same version, you get roughly the same thing built. So shrink wrap is the thing that is meant to do that, but it's not bulletproof. NPM has a thing called dev dependencies, which are kind of like dependencies, but for development only. And these confuse the hell out of NPM. And sometimes things start to creep along, even if you have a shrink wrap. So it kind of works. It has downsides. It writes a very detailed file about what it thinks the dependencies, like where they are and how they should be checked out. And that file sometimes changes because NPM changes. So when you commit something to Git, you get sometimes humongous diffs because some format changed in shrink wrap, and that just confuses again stuff all around. So yeah, it works. Totally, like NPM totally works, but it's not bulletproof. So just something to take into account. You will spend time here. Right. So that's about the language. Let's move on to other topics.
All right, as Matti mentioned, our background is web development, and getting started with desktop development provided us some challenges or things we didn't consider before, and I would just like to share a couple of ideas or a couple of things we noted. So whenever you're doing web development, you will constantly have access to your live logs, you will have access to the overview of how your app is behaving, what the users are doing. Once you start doing desktop development, you're shipping a product that you will have way less control over. So there are a couple of approaches, like how to understand how the application behaves or what it's doing is by maybe collecting usage data. That's what we are also doing. But the thing with that is you still don't get any live overview of your users. You will eventually get some data if the application decides to send you that data. And you also need to set up some external service where the application can send your data to. So you can start building your nice looking graphs and collecting metrics. The good thing for users, bad thing for us developers is that users can actually opt out and they can say, hey, no, you will not touch my data, it's mine. With error reporting, it's kind of the same story. Everything that's happening is happening on the customer's machine. So if error occurs, it might get logged. But if it gets logged only to the local file system, into her log file, then there's not much we can do about it or do with that. So you also need to set up an external service for tracking errors, and you need to make sure that whenever anything weird happens, which is not user-caused error, it has to be reported and sent to your server. And that sometimes also fails. Like as a backup measure, you have to make sure that users have have a way to tell you that, hey, when I'm doing this or that, this thing is not working. Or the user would want to say like, hey, this application is awesome. So what we have done is we just provided a feedback form where you can checkbox, include log files, or include my system information. And you can give us like thumbs up or thumbs down or improve suggestions for improvement, stuff like that. Has proven to be very valuable. All right, software deliveries world, way different world now. It's our previous practice was like releasing a software maybe 10 times a day. Like whenever you felt like your feature was done, you would deploy it to your production and you're done with that. With current desktop releases, it takes way more time to get a release out. Our schedule plan has been currently like once a month or something like that. So from 10 times a day to once a month is a big leap. Installers, yes. If possible, whenever you are doing desktop development, try to use the installers that are provided by the ecosystem or the Electron itself. There are a couple of good ones out there which unfortunately didn't fit our need because we have a bunch of dependencies that can be handled by simple installation process. We also have sister applications that might be sharing some of the dependencies. So we ended up writing our own installer, and it has proven to be hard. We actually had a dedicated team for just that. And working within Windows installers is no walk in the park, I would say. So yes, we built our own custom installer. We also made it look fancy. We added its own look and feel. We made it as a separate Windows application, actually, using the VPF, Windows Platform Foundation, or whatever, the one you use for doing the desktop GUIs. Once that was done, okay, we got our installer done. We ran into another issue. Every installer you ship has to be signed in order the customers can trust you. So when you're doing installers, there are, at least we had two options for signing your installer. You can purchase a certificate file for signing your installer and start signing. Yeah, that's what they said. And the other option is you can buy hardware token, which it's basically a USB stick. You insert it into a machine, and every signing process has to go through that USB stick. So there are benefits for both of them. First of all, when you're using file-based approach, it scales really well. Like Matti mentioned, we have 18 agents or DMCD agents for CI process, basically. So we can tell like any of those machines can build me an installer. Whenever I'm done implementing a feature, I will commit, and eventually I will have installer ready. So it scales well, but Windows doesn't trust software that is signed with certificates like that to some extent. If that software hasn't been installed, let's say 100 or 1,000 times, it will give the user still a warning that, hey man, are you sure? Do you really want to install it? It's from that company, but I wouldn't install it if I were you, basically. So that was actually quite disturbing. But internally, we have been testing that a lot of times and talking to internal customers, and we actually overcome that issue over a time when the installed amount got big enough. The other approach would have been the hardware token. That doesn't scale at all, so you would only have one machine that does the signing for you. And with that approach, the trust issue would have gone away. It costs more, but it doesn't scale well. Yes. So that's that. That's what you can do about it. Auto-upgrading is also hard. Whenever possible, use the existing tools. These work, like seriously. You don't want to invent the wheel here. We did that. Problem with auto-updates is you want to make sure that I don't even care about the application itself. I want to make sure that the auto-updater works. The one that's able to download your new patch whenever I have made a mistake in my main application. So when the auto-updater fails, the customer will be stuck. And maybe it can fail in a way that the customer even doesn't know that the new software is out there. So if that happens, you end up supporting or providing backwards compatibility for a very long time. And testing out upgrade, if you are planning to implement one on your own, then it's kind of tricky to test that approach. It's super easy to test whether my old version got updated to a current version. So let's say I added a feature, and I will test whether that machine got updated to my current version. That is easy. But how do you know that the software that I just released to the customer will actually be able to out-upgrade in the future when our next release is coming out? So I don't have an answer for you. We ran into that issue ourselves. It's kind of tricky problem to solve. All right, like a couple of you were desktop developers. In our house, we actually have also several desktop developers who have been doing CAD development, I think, mostly. And we just collected some ideas to understand, like, how do these guys feel about the technology stack we are using right now? Do they feel comfortable with Electron and JavaScript? So here are some ideas that we collected. All right. If you take the .NET world, it's kind of stable. The releases don't come out like every day, and the software you have been using is something you're familiar with. With Node.js, not especially with Electron, but with Node.js overall, everything seems to change a lot. Node.js itself has releases, I don't know, maybe twice a year or even more. I mean, the major updates. Minor will be coming in even more sooner. So some technologies we chose have been already replaced by better ones. So we started a year ago. We thought that the React Flux approach is a cool thing. We picked one of the implementations for Flux, and like after half a year or later, a bit later, we already knew that we are almost dealing with legacy software. There are like 7 other libraries out there that are doing the same job, but in a better way. We have gone over doing the Node WebKit development. We switched to Electron. We have started with Node, then switched to IO.js, then back to Node. Electron itself sometimes is buggy. You are waiting for next release for something internal to change. Yes, so about the ecosystem. Probably all of you have heard the saying that opinions are like assholes. Everyone's got one, right? So same applies to JavaScript. And I disagree with Matti. Matti said that JavaScript as a language is unopinionated. I think there is not one opinion. The problem is that there are a bunch of opinions out there. And every developer tends to know best how to approach this problem. So there are like several ways to achieve the same result using JavaScript. All right, one example would be promises, a library. Let's say you start doing your Node development. You would like to pick a library for promises. So there are at least, I can name 6 that can do the job for us, and they are compatible by some standard. So there is Q, Bluebird, When, RSVP, BOW, and finally the ECMAScript 2015 started supporting that as well. All right, that's a big choice. Once you have made your choice, maybe after half a year or so, you will find out that half of them are no longer maintained. Like you end up using something that's already old, right? Okay. So every library itself is a world of its own. Matti mentioned that styles are different. The way the code is organized is different. The one part that seems to bother people, at least in our house, is the lack of documentation or the way that they provide the documentation. One .NET developer told us that he really likes the way Microsoft organizes the documentation. I can kind of relate to that. From JavaDoc, I can also remember that everything is actually easily organized. You can easily look up stuff you need.
Yeah, but in case of Java and Microsoft, you talk about standard libraries, but in world of JavaScript, there's basically custom tools, all of them, most of them.
Yes, the ideology of Node is to ship just a tiny core product, and everything else is provided by open source people around the world, right? With full-blown libraries like .NET or Java, you will get everything with your VM probably. So with no libraries, you end up reading the README first, like that can be a long file. Once you're done that, you still might not clearly understand how things or pieces come together. So then you start digging around the code. Luckily, the code is readable, I like that. But once you're start using the library, whatever IDE you choose, that documentation is not there while you're typing your code, or the content assist does not work nicely. So even if you pick the most fancy ones like IntelliJ or WebStorm, it's like, they help you out in several ways, like they're actually really good tools for that, but documentation part is lacking. And talking about IDEs, there are also like, I mentioned too, there is also Atom and Visual Studio Code, and some people use Vim. Like, selection is great, everybody likes that, I can pick my own tool. It becomes a problem when everybody in your team decides to use a different tool. So if one guy doesn't have a code checks on, then my IDE will complain about it. If I haven't maybe set up my continuous integration to check for those errors, then my IDE will complain about those issues.
But why don't you do sanity checks like within your deliveries?
That's what continuous integration is for, yes. We actually do that, but if you don't start with nothing in the beginning, you don't have that. So there is a lot of like manual labor involved to get things running smoothly. So one guy in our office said, or in our sister office said, that Visual Studio is awesome. And I think I can relate to that as well. I don't know Visual Studio very well. I'm really bad at that. Using that, it's too complicated. But if you are in the zone, you have all the tools available, and you don't need to overthink things. Like you check out the project, you can compile it and probably run it. All right, how much time do we have? Okay, let's talk about debugging for a moment. I mentioned main process and renderer process. It has bothered me. It's really weird. It's something I didn't understand in the beginning. You look at your code base, you have all the same JavaScript all over the place. But debugger will only work, let's say in main process, you will be using one debugger. In renderer process, you will be using another debugger. These are running in two separate processes that have actually not much to do with each other. So for main process, you can use your IDE or whatever, or you can install libraries like Electron inspector, so you can attach to that debugger process and see what the process is doing. With the renderer process, the Electron provides its own tools, which is actually nice. These are really good set of tools available. All right, we had issue with network traffic. Since we are not using the, let's say, the stack that Electron itself provides, or the renderer part Chrome provides. Like if you had let's say, Ajax calls, this is stuff that is visible to the browser. But if you're accessing Node API directly, this is stuff that Electron debugger doesn't know anything about. You will end up seeing 0 requests, but you know that things are happening. And it also takes a while to understand what's causing this. Just something to take to pay attention to. And memory profiling. It's also awesome. JavaScript tools in Chrome have actually really decent set of tools available. But the problem with JavaScript itself is that every function that gets invoked, it gets assigned a context with that. So if you're, let's say, referencing a variable that was outside the function itself, so you will get a big context with your invocation, right? If you're doing memory profiling and you're comparing snapshots, you could end up seeing that, hey, within the last minute, we got a million new system context objects. And that can mean anything. They are similar objects coming from all over the places. So you can't easily tell at times what is actually leaking. We had that issue before, so that's why I'm mentioning that. Also, guys are missing code compilation. You are actually shipping out your own source code that is easily available and readable for everyone else. I mean, it doesn't bother us, but for some people it's important. There is one way how you can like make sure that no indexing is done on your files maybe, or the Electron provides a way to pack your files into a single file. It makes also installers' life easier, so you don't have to copy a million files over. You can just copy one file. So with Electron, there is a file named azar. It's basically a tarball where you can have random access to any location in that file. It's not packed, it's just like concatenated file. It's more complicated than that, but basically that's what it does. So I encourage you to take a look at, let's say, Slack. Find out where the Slack is located. Find the executable. Next to that, you will see a directory named resources. In that directory, you will have app.azar file. At least in Windows, I just verified that today. And you can unpack that file. And you can, once you have unpacked the file, you will see a bunch of node modules and source file that Slack consumes. So your only approach would be actually uglifying your code if you're worried about that. But not much you can do about it. If you really want to hide your secrets, you need to use C or whatever, some other approach. All right, I have been complaining a lot. It's actually not that bad. Life is good while doing Electron and node development. Seriously, it's awesome. So let's talk about some of the benefits of using a stack like that. So we can use all the web development experience we have in-house, and we can start creating a desktop app. So how awesome is that, right? We can use the latest and greatest UI technologies out there. I have been trying to write the VPF products before, and it's pain in the hell to mess with the alignment and input boxes. And I'm talking about the Windows GUI framework. It's pain. With CSS and HTML, it's a breeze. Matti also mentioned we are running Angular and React within the same application. So it works. We can design a separate teams to do their own stuff, and we can make those components play nicely with each other. Portability is also a benefit for us. Our application is actually, the sister application of ours is actually running under macOS. Ours is running under Windows because we have native dependencies. The application itself doesn't look and feel like a native application if you think about the square buttons in Windows or like stuff like that, but that doesn't bother us. If it's something you're interested in about, then that world is probably not for you. Go ahead.
Is there any CSS libraries available to mimic this OS native controls for OS X or Mac OS and Windows? Like I remember when Cordova
there probably is.
I remember when Cordova was a thing, then there was this CSS library to mimic this iOS 7 controls, button toggles and stuff.
I'm pretty sure there are more than one library for that, especially in Node world. Some of them are not maintained anymore, but some of them are. All right. Code reuse. As you saw, the schedule part was running in desktop. It was also running in browser. And we also have some internal components that are running in desktop, and we also have a cloud-based server solution, which we didn't mention at all. Like we have Node server running somewhere in the cloud. And we are actually using same parts of the code there as well. So this is nice. You don't have to do the mental switch when you're doing like separate pieces of your full product. With Electron, you also have less to worry about the browser compatibility. You are just producing content for one specific browser. And doing that is actually super easy. You don't have to worry about whether I can use the latest technologies out there. If it looks good, you can use it.
So this app installation brings in this Chrome instance to the machine?
It's Chromium, I think, and it's like the new part of the Chrome. So they are sharing like 90% probably. But the rendering part and process handling is the same you have in browser.
And this application doesn't know that there might be original Chrome browser in the system. So
As it doesn't affect you in any way. One thing to note actually is like the demo app I created was maybe a couple of kilobytes or even less. But once you bundle that, you will get you need to ship the Electron, which actually includes the node runtime. You will get an application maybe 70 megabytes or 80 megabytes. If it's not an issue, you can do that. All right, a couple of last points I would like to make. So developer tools, I'm not going to mention that. You saw that actually that debugging tools available for you. For debugging even the shipped application is awesome. I don't need to do anything extra. And JavaScript is single-threaded, which means I don't have to worry about like synchronizing data access or thinking how one thread is behaving when the other thread is doing other things. The callbacks can cause, yes, issues if you are stupid enough, but overall, life is easy with single-threaded approaches, right? That is all I wanted to tell you.
So yeah, we went through some of the challenges, we went through some of the upsides. So maybe just to round it up, as a conclusion, we can say from experience that yes, the Electron approach is something you can take. You can take a bunch of web developers and build a desktop application. It actually works. There's a bunch of work you need to do, but I guess if we did it again, we would probably take the same approach.
Would change a couple of things, maybe.
Yes, let's do less mistakes, fewer mistakes, but yeah. Right, so that's what we had. Maybe just a quick note in the end. We didn't talk about 3D printing much, but we have learned a bunch about 3D printing in the last year and a half. So we're thinking of doing, or like we will be doing a workshop about 3D printing. So we have a bunch of technology available. So if you're interested, make sure to sign up. We'll show you how that world works. And
we have also a bunch of cool-looking printers, which can
we have a
produce
bunch of
things like that.
A couple of examples here. If you see, these are 3D printed actually. They don't look like it, but they are. So
try on the shoe.
Please don't if you're Dutch, unless you're Dutch. Right. So that's what we had.
Thank you.
Yes.
You said there's about 60 contributors to the project. How many of them were working full time?
All of them. Not all of them work on the projects. There are a couple who are like project leads who did just a change or two, but that's majority of them is developers.
Then we actually have like more going on than that one desktop application. There are actually subcomponents that are developed by separate teams, and once in a while, a team member from that team can come in and commit something into our application. So it's not like full time in that sense.
Yeah,
right.
We work in like vertical teams where you have a feature and you will build it from like we try to work it so that you build it from UI down. So you will end up working on some process that runs out of the UI itself, but you will end up working on the application also to add it there. So in that sense.
Have you tried porting the same application to mobile devices?
No, it worked actually.
Okay, there is like yes and no. The same Electron app, no, we haven't tried running that on a mobile, but the components that we run, that's the bit that we wanted to run on the mobile. We have done prototypes of running the same print preparation in a browser, and that works in mobile.
So yes, we mocked out all the file system access and everything that is specific to Node. Made sure that it runs in client-side JavaScript. But it doesn't work with mobile as well because it doesn't. We haven't added a responsive design to our application because it doesn't make sense in our case.
So you mentioned that you were using both Angular and also React in the project. Were there any challenges of making these two frameworks work together, or what was the eventing the only way how they communicated?
No. These don't actually use the events. These are actually two separate libraries accessing your DOM. Okay. So basically, they have access to everything. The way they get rendered is just different.
Well, we share, like the services layer is shared between them, but a lot of the model between them is actually not shared. They are like built for separate purposes. So we didn't have much interop problems at this time, so we could reuse the services just JavaScript. So.
Yes, the last one.
You told you also working with Java world before.
Yes.
Why you moved to JavaScript for desktop applications?
Okay, GrabCAD has actually been mostly about SaaS, or the software that we provide as a service on cloud. Once we got acquired, we actually we were challenged as a company to prove our worth, I would say. Can we actually produce something for our mother company? So we had the know-how how to do web development, and this seemed like actually a very good way to use our skills for that purpose. So basically, we're still doing web development with a different approach.
And not all of the companies are Java-based. Like 60 people, we have people with all kinds of backgrounds.
So yeah, GrabCAD is not Java-based. I was before I joined GrabCAD. So in GrabCAD, I'm doing everything but Java.
Okay. Thank you, guys.
Thank you.
It was nice to have you for the talk.